There we go. And when updates happen and it turns off features on my iPad. The microphone. All right, so using our synthetic substitution up here, the way we set this up is just like synthetic division. We're asked to find f of 1 of this function here. So when we're setting up our synthetic, what are we going to put? How do I set this up?
Drop everything down.
What do you mean?
Like
The 2,
the 2, the 1.
The 2, the 1, the -3, and the -5. All we want are the numbers, no letters. I just can't skip any. So we started with an x cubed. We had 2 of those. We have 1x squared. We have a -3x, and then we have our number. So I cannot skip any pieces. What's going to go in the little box here? The 1, the thing we're being asked about. Now we're in our process where our first number drops all the way to the bottom. All the way to the bottom. What's going to go here? 2. Good. What's going to go here? 3. Here. 3. You're on a 1. Here. 0. Good. Here. 0, because 0 times 1 is 0. So the bottom one? -5. So what is our answer for the value of f of 1? -5. This guy is the answer for the substitution. Nope, just the remainder. Just the remainder. Because if I went through and I substituted in a 1 here in place of every single x, so 2 times 1 cubed plus 1 squared minus 3 times 1, I would wind up with -5. Because it's the exact same value as substitution. It's just done in a less I have to be super careful typing things in the calculator way. Same vibe on the bottom one. Very same vibe. We're going to have our little box. We're going to draw the line across. And we need to take our coefficients in here, making sure we don't skip any. So I have my 3x cubed, my 7x squared, minus 4x, minus 28. If we have a term that's missing, that's when we put in a 0. We don't have any pieces that are missing here, so we don't have to worry about it, but I just like to remind us. And we're asked on this one about g of -2. This is our function g. That's the guy that goes in the box. That's what we want to know about. Our first term always, always, always drops it all the way to the bottom. What is going to go here? -6. Because we take the bottom times the left and put it under. 3 times -2, we get -6. And we add these together. 7 plus our -6 gives us a 1. Which means our next piece is a -2. Which gives us, when we add them together, a -6. And then our last piece. Yep, +12. And so what is our answer for g of -2? Yep, so g of -2 is going to be this -16 over here on the end. Okay, questions on these ones? Okay, let's do our practice SAT question so we can talk through it. I want you to take a look at this one. And Stephanie, are you doing 2 or 3 quiz?
The one we took
Yesterday. Okay, cool. That's 3. And I haven't put those away yet. Somewhere. I got it. I found it. That's right. So here's our little SAT practice question before we get cruising. And they're asked to find, or we are asked to find the minimum value of the function. So we want to know which of these could be an answer for this and is the smallest. Which one did you say? Mm-hmm. What makes you think B?
Well, it's always going to be there. Like if you put a 0 there.
Yeah, the very, very smallest we can make an x squared b is 0. Because if x is 1, it's worth 1. And if x is -1, -1 squared is also a positive 1. So if I say 2 squared would give me 4, -2 squared is a positive 4. So the very smallest an x squared can be is 0. So if we have a 0 in this spot, we still have this plus 55. So that's the very, very smallest it can be. That is absolutely a valid way to logic our way through this one. If we remember our like parabola stuff, you can think about our vertex form where we had our ax plus h squared, x minus h, excuse me, goodness gravy. X minus h plus k. Where we have our vertex at 0, 55, which would be our minimum because the vertex is always a minimum or a maximum. But this is 100% a very, very logical way to go through it because yes, B is our answer on this one. It is the very smallest we can get this thing to equal. So just make sure we're looking at these carefully, give them a gap, all that jazz. Okay? What we're going to be working with today is we're going to continue working with the find all factors stuff. That's the one we did yesterday. This one. That was the only one that actually got yesterday.
Did you count the goose chips?
No, I have them graded, but I haven't talked about that yet. I should be able to do that today. I just want to make sure we get through what we need to first. All right, let's take a look at this. We are asked to find all of our roots. So I want to get all the way down to a solution, and x equals, given this polynomial, so when it says get all the way down to roots, it means we need to get down to our x equals, or we need to get down to our order pair where we have our x comma 0. Either way is fine. I think the x equals is usually easier, but we're getting all the way there. So what they've done is they've given us a polynomial here, and they're going to tell us one of our factors. Because this guy, if I went in here and tried to do this with my factoring by grouping stuff, it's not going to work. I won't wind up with the same thing matched up. So what we're going to have to do with our factor that we're being given here is we're going to have to divide it out. That's one of the benefits of doing that synthetic substitution is it reminds us our synthetic division again, because we can do that. So we want to divide out this factor from this whole polynomial, so we're going to use our synthetic division. So it's going to pull all those old pieces together again. So our synthetic division, I was writing it out. Forgot the T. Synthetic division. And if it's not spelled right, it's close to dang enough. So we're going to do our synthetic division over here. We have our little box, and then just like we did in the bell work, we're going to take our numbers from in front of each one of those terms. I've got my 1x cubed, my minus 4x squared, my 1x, and my 6. We're going to skip a line, draw a line. And then we have to figure out what's going in the little box up here. What's good? How do we know it's 3?
Because you do x minus 3 equals 0.
Yeah, since we're given a factor, we need to find the root. So we set our factor equal to 0. So we want to see x minus 3, add 3 to both sides. We want to see if 3 is a root for this polynomial. That's what they're asking us to prove. So the 3 is what goes in this box over here. Questions on the setup on this one? Cool, cool, cool. Then we're into our process. First one always drops. Drop it like it's hot. Drop it like it's hot. So now I want to, like my brain is trying to get me to make a shorty drop low reference. That's okay. It's old songs anyway. I was like, y'all don't catch most of my references anyway. It's all good. It's just my little millennial heart. All right. So then we're going to do just like we did in the bell work. 1 times 3 and it goes under. So 1 times 3 gives me 3. And then we add our negative 4 plus 3, which is negative 1. Bottom times the left and put it under. Negative 1 times 3 gives me a negative 3. And we're going to add those together. 1 plus negative 3 is negative 2. Negative 2 times 3 gives me a negative 6. And what do we get as our remainder here? 0. That's what it means when we say show that this is a root or prove that this is a root or prove this is a factor. So if we ever say to show or prove, that proves it. When our remainder is 0, that means this comes out nicely and we have something left over in our polynomial here that has no remainder. So we divided that thing out evenly. What is this thing aside from a series of random numbers? It is a polynomial. What degree is this first piece going to have? That's going to go with the x squared because it always goes down 1 degree when we do synthetic division. We started with a cube, so we're going to wind up with a square after our dividing. Then it's going to go down a degree. So it starts with a square, so it's going to go down to an x. And then our last piece is going to be a number. This is why it is super important that we do not skip any terms. So we had the one yesterday where we had like x to the 4th and then an x squared, and we have to put the 0 in, otherwise we don't have enough pieces down here for all our coefficients. We've got to have a column for everybody. So what we have here is we have our quadratic polynomial that would be our 1x squared minus 1x minus 2. So that's what we get from our synthetic division. We weren't just asked to divide it though. We are asked to find all roots. So what I'm going to do is I'm going to bring my quadratic up just so it's not at the very bottom of the screen, so that we have our x squared minus x minus 2. And we need to find the roots of that guy. How do I find the roots on a quadratic? Factoring. You can use the x in box. We can factor with the splitting and grouping. I feel like a lot of us do tend towards the box when we do it on our own. This is where we take our a times c at the top and our b goes at the bottom, which we can get from our quadratic, or we can look over here and realize, hey, my a is with the x squared, so it's going to be this first number here. This guy is my pen that's not working. Love it. Factor it fully.
But we're trying to find all the roots
Yep.
of the equation.
Yep. And we need all the roots, which means I need to know the roots of this guy too, which means we got to keep going and keep factoring. So we're factoring fully. So my a is the 1 and my c is the minus 2. So we're looking for a pair of numbers that's going to multiply to make negative 2 and add to make negative 1. That's my b. So what pair of numbers is going to multiply to make negative 2 and add to make negative 1?
Negative 2 and 1.
The only things that I know of that multiply to make 2 are going to be 2 and 1. And if I need to add them up to be a negative, that guy needs to be negative. So what that lets us do is we're going to take our x squared from the equation and the minus 2 from the equation. And then these two numbers in the middle are what get this variable. So we're going to have our minus 2x and our 1x. Pulling our factors in columns and rows. What is shared between x squared and x? Just an x. What is shared between minus 2x and minus 2? Minus 2. What is shared between x squared and minus 2x?
X. Why did?
That's okay. It's because it's 7:35 and brain is not braining at 7:35. Takes practice. What is shared between 1x and minus 2? 1. My stomach decided to chime in on that one. Good Lord. So what this tells us is our factored form for this quadratic is our x minus 2, x plus 1. If we wanted our factored form of this whole polynomial, what piece would we need to include in there to get our f of x fully factored? What is this missing?
Then X minus 3.
That guy. So this is our fully factored form of our polynomial. So this equals our f of x fully factored. But we aren't just asked for fully factored, we want roots. But we need to be in factored form in order to find those roots. What are our roots going to be?
Plus 3. X equals 3.
Yep, x equals 3, this one up here.
X equals 2.
Mm-hmm.
X equals negative 1.
Yes, because what we're doing is we're setting these factors equal to 0. So x minus 2 equals 0 means, oh, it's not going to be negative 2 though. Positive 2. X minus 2 equals 0. We'd have to add 2 to both sides. And then our other one over here, x plus 1, is going to give us a root at x equals, careful, that one's going to be negative because x plus 1 equals 0 means I need to subtract 1 from both sides. X equals minus 1. So this is what we want for our answer in this little box. This is what we're aiming for. It just takes all this other work to get down to this answer here. This is what we're looking to find. Okay, so that's the goal for today.
We did it a few times.
Mm-hmm. Let's look at this one. Because we're going to find all roots for this polynomial. We're given a factor. Just find out, sometimes we give you a factor, sometimes we give you a root. If we give you like an x plus 2 kind of situation, that's giving you the whole factor and we have to find the root. If we say the root is 3, then that's just the number that goes in the box. So this is going to write down the polynomial. I'm not going to push this through. Because honestly, we're in a good place because y'all were the only group that actually got through one of these yesterday. So we have plenty of time. All right, so our f of x, we've got this 4x cubed, our 19x squared, our 19x, and our minus 6. I say, this one would definitely not factor by grouping. This is not going to be a thing we can work with here. So we definitely have to divide. So we're going to set up our synthetic division. You can do long division, but that's kind of mean to yourself. I don't recommend it. Long division is icky. So we're going to set this up with our coefficients going across. So we're going to have our 4 from our x cubed. That guy's first. Then we have our 19 from the x squared. Our 19 from the x. And our minus 6. Grabbing just the numbers from our polynomial up here. What's going to go in the little box? -2. That's when we take our factor that's up here. This gives us our first root, our x plus 2, and we set it equal to 0. So our first root is that negative 2. Ooh, here we go. That's what's going in the box. We divide by the root with synthetic division. Skip a line, draw a line, and we're ready to rock and roll. The first term always drops all the way to the bottom. I don't know why, but that's a sticking point for some people. Do not add chaotic things in the middle. Don't make up something to go there. Don't put a 0 in the beginning. So the first term drops all the way down to the bottom. Then we multiply and put it under. So I'm going to take my 4 times my negative 2, and we're going to get a negative 8. 19 plus negative 8 is going to give me a positive 11. Then we're going to take our 11 times our minus 2 and put it under. That's going to give us a negative 22. And we're adding those together. 19 plus negative 22 is going to give us a negative 3. Negative 3 times negative 2 gives us a positive 6. And we're going to end with a remainder of 0. When we are asked to find all roots or divide, things like that, that's when we should have our remainder of 0. Because if I was to substitute in negative 2, we would get a 0 as an answer. That's why our roots are also called our zeros. Roots, x-intercepts, zeros, solutions. Y'all can get sick of me saying all those words, but I say them all the time. Okay, questions on the synthetic division part? Cool. Because our next piece is to look at the what we have left over bit, and remember that this guy is going to have what power with it? X squared. And this guy's going to get my x's, and this guy's going to be a number all by itself. Which tells me that this is my A term, this is my B, and this is my C. So just like with our standard form, AX squared, BX, and C. So my quadratic is our, not bad. There we go. 4x squared plus our 11x. And then our minus 3. So this gives us our quadratic that's left over. I don't want that as fluorescent pink. Questions on that bit? Because now we need to look at this guy, and we need to find its roots. So we're going to need to see if we can factor this thing. So we can come down here. I'm going to do it extra just because I don't have to be at the very bottom. I was like, I could keep this all going and have it be in a column, but that makes the back row very difficult to see it. So we're going to take our A times C at the top, and our B goes at the bottom. So my A is 4, my C is negative 3. 4 times negative 3, we get a negative 12. And my B is 11. So I need a pair of numbers that's going to multiply to make negative 12 and add to make 11.
12 and negative 1.
If that's a spot where we struggle to find a piece here, because that is sometimes where we struggle, make a list of things that multiply to make the top. So 1 and 12, 2 and 6, 3 and 4. Since the top number is negative, we're looking at the differences. The pair that has a difference of 11 is my 1 and my 12. One of them is going to be negative, and since the bottom number is positive, it's going to be the littler one. So that's a kind of way to talk yourself through that process there, just because I know for some of us, that's where we get stuck in the factoring. So I'm going to use the box again. You can use our grouping method. You can use whatever method you like for our factoring. But inside the box, that's where we're putting our 4x squared from the equation. We are putting our minus 3 from the equation. The other two pieces are coming out of the x frame, our minus 1 with the middle variable x, and our 12 with that middle variable x. That is a 12. It is small when they're touching. So pulling our factors, columns and rows, we're going to get what in our first column? What's shared between 4x squared and 12x?
4.
Mm-hmm.
4.
4 and x. Good. What is shared between minus 1x and minus 3? Minus 1. Negative 1.
Wait, how can you put 12x?
Because that was this guy here.
The x?
And the x is because this is where we get this thing. We're uncombining the like terms from our 11. So if I was to multiply whatever we get here with this guy and combine them together, it should wind up back here. So it's uncombining that center. And this is just a tool we can use to do that. So let's do our rows now. What's shared between 4x squared and minus 1x?
X.
An x, just an x. And how about our bottom row, 12x and minus 3? They have a 3. So my factored form of this quadratic is our 4x minus 1, our x plus 3. To get our factored form of the whole polynomial, our f of x, that's when we go back and grab up the one we divided by at the very beginning, that x plus 2. There it goes. I got it. Look at it. This is our whole f of x in its fully factored form. All the way down in factored form. So we love that. That is a beautiful thing. It is not our answer that we're like totally looking for, but it is super important for us to get there. Because in order to get there and find our roots, we need our factors so that we can get there. So our roots, we already know one of them. What's one of our roots?
-2.
-2. It's that thing we divide by all the way back at the very beginning. What about this one? -3. Good. X plus 3 equals 0. We subtract 3 from both sides. We get our x equals minus 3. What about this one?
-1 over 4.
Super close. Just be really, really careful. Because our 4x minus 1 we said equal to 0.
Wait, it's
Watch that sign because we need to add 1 to both sides. We get our 4x equals 1. Which means what does x equal?
1.
Yep, we got to divide both sides by 4, so we get 1/4. So we're going to have times when we get fraction roots. You can put them as decimals if you really, really want to, if you hate fractions that bad. Doesn't matter. Means the same thing. If we're looking at thirds, I'd recommend fractions for sure. But fourths or something that winds up with a short decimal, it's fine. Okay. Questions on these? We're going to stop there. That is not the homework we have. We have homework 5-3. And that is still very much out of date. That's called I have had other things happening. So we're working on homework 5-3. That's what all those ones are below the synthetic division problem from yesterday. I do not think I've actually put them in the folder yet. I think I have them over on my table. So when they're giving you these problems, they're taking our polynomial. Like for 24, it's that x to the 4th, our 2x, that's a 4, there we go, 2x cubed minus 8x minus 16. When they put this little colon here, what that means is you're going to divide it by this piece afterwards. x plus 2. So we're giving you this as the factor for you to divide out of that. Okay, so just because it was a weird kind of way of wording it, I wanted to make sure we pointed that out. So some of them will just say factor. They all just say factor. Find the remaining factors. See if you can go all the way down into factored form. You will not always be able to. Some of them are not further factorable. But it's important for us to be able to check that. Okay. What I'm going to do is I'm going to grab the skills checks and the homeworks and stuff, and I'm going to pass those back. You guys have the next 8 minutes till announcements, almost 15 until the end of the period.
Can I get homework one?
Say it again?
Can I get homework one?
Yeah. Oh, there's no more homework ones in there?